dealing with the chapter on integration today, right? As we have discussed in our earlier chapter, we have discussed at length the differentiation. So what the calculus world talks about is the integration is nothing but the reversal of differentiation, right? So in our earlier chapter when we said x squared, the differentiation of x squared is 2x. It means if I do the integration of 2x, typically written with something like this, the integration of 2x is nothing but x squared, right? So this is one of the simple relationship that exists between integration and differentiation. Sometimes if someone asks you to integrate as a simple question, if suppose there is a question which says do the integration of x cube, the simple way to try to understand this is in your option choices try to differentiate. If you are not comfortable with integration and if the question is as simple as this, probably try to differentiate or find the derivative of your answers, and whichever answer gives a value equal, whichever the derivative gives a value of x power 3 or x cube will be your answer. So that's one more way you can use your derivatives or differentiation to do the integration. But yes, keeping that thing aside, it's better to understand the world of integration because not everywhere we work only with the multiple choice world, and probably as a space in the actuarial sciences we have to use the fundamentals of integration at a lot of places. So having a grip on the world of integration and differential equations and these kind of concepts definitely adds value to our analysis. So with that as a background, let's get started. As I just now said, derivative integration is nothing but the reversal of differentiation. So that's one thing. And integrals typically they are represented with something like this. So integral of x squared. Sometimes what happens is there won't be any boundaries here. It is like indefinite integral. When nothing is mentioned as a lower limit and upper limit in the integration, we call them as indefinite integrals. Whereas when I see some numbers here, probably 3 to 4, some numbers, when I see some quantities here as the lower limit and the upper limit, we call those kind of integrals as definite integrals, right? Lot of applications which we use in the real world will be evaluated as definite integrals itself. The moment we get comfortable with the indefinite integrals concept, we can very well apply the definite integrals concept also to that. And the prime reason why we do an integration is to find the areas or to do the summations over a continuous period of time. Summation over continuous period of time. If the summation is at discrete periods of time, probably we can use sigma. But if the summation is over continuous periods of time, sigma is what will get translated into your integral. So that's the kind of relationship you can think of. Whenever I want to find out the area between underneath a curve or summation of something over a continuous period of time, I would refer to or I would depend on the usage of integration. So just like the world of differentiation, we will definitely see some kind of common formulas that can be used to do the integration, and using those common formulas we can definitely do the integration of some of the functions. And wherever they go complicated, wherever a direct formula cannot be used, we have various other alternative methods of doing the integration. That is what is we would be spending as a part of this particular session. The most common integrals, the first thing we have to understand is integration is always done with respect to one variable. Just like we used to say in differentiation, d by dx. It means I am differentiating with respect to x. D by dy. I am differentiating with respect to y. So, just like the way we did that in differentiation, in integration also, I will not leave it just like x squared. Probably I need to have either a dx or a dy here. Now there is a difference between the two. If I am using it as dx, okay, then x is a variable. So this x is treated as a variable and then integrated. But if the same thing becomes x squared dy, which means y is a variable. So that means x squared is not a variable. X squared is a constant. So it does not go with x or x squared here. The integration is done primarily with respect to the variable which we are mentioning as a part of dy. Remember this. So if it is mentioned here as dx, then x becomes a variable and the integration happens as if x is a variable. But if the integration is find the integration of x squared dy, then y is a variable, which means x is treated as a constant and the integration happens with respect to the constant x squared. Then some of the most common integrals which we come across. Integration of a constant a dx is nothing but ax plus some k constant. This is one important rule, it's better to remember. If you have integration of x power n dx, so that becomes x power n plus 1 divided by n plus 1 plus some constant c. And if I have this integral of 1 by x dx, it is nothing but log mod x plus c. Because integral is defined, log is defined only for positive integers. So that's where I am taking log mod x plus c. And if at all I come across any integral where its derivative is there in the numerator and the actual value is there in the denominator, I will directly take it as log f of x plus c. For example, I'll give one example here. So if someone asks me, find the derivative, find the integration of x squared plus 2x plus 3 in the denominator and its corresponding derivative is there in the numerator, 2x plus 2. That is the derivative of x squared plus 2x plus 3. So derivative is there in the numerator and the actual expression is there in the denominator. So f of x is in the denominator and the derivative of x is in the numerator. Then I don't need to really solve for this. I can simply write log f of x. So in this example, I can very well write it as log mod x squared plus 2x plus 3 plus some c. So this is one more formula which you need to be comfortable with. Then if someone is talking about integral of a power x dx, x is in the power here, then I'll write it as a power x by log a plus c. One more formula was, these are very common kind of. Then again if I have e power kx dx, then I will write it as e power kx by k plus c. So the first thing is you need to really remember these 5 or 6. Probably the best way is if you try to differentiate this or differentiate this. What is the derivative of log mod x? Log x is 1 by x. So this is what you got here, right? if you try to find the derivative, let's say e power kx by k, what is the derivative of this? 1 by k e power kx into k, which is nothing but e power kx. That is what we got here. So this is nothing but the reversal of the differentiation itself. But to do things slightly quickly, at least these 5-6 common form of integrals, if you are comfortable with, you can solve some of the integration related questions quite comfortably. And what if the question contains a definite integral, the same expression? Let's say if someone asks me, find out the derivative, find out the integration of 2x plus 3, x squared plus 3x plus 4. Now I know dx. So here if someone puts a definite integral saying between 2 and 3, it is nothing but first do the integration as it is. Forget about the limits, forget about the interval, forget about the definite integrals here. Evaluate it as if it's an indefinite integral. And what process I can use here? F dash x is there in the numerator, f of x is there in the denominator. So I can very well write this integration as log x squared plus 3x plus 4. And because it's a definite integral, this entire thing I will bound it between 3 and 2. What does that mean is, first I substitute 3 in this expression, log 3 squared 9 plus 3 into 3 9, 18 plus 4 log 22 minus, now substitute 2, 2 squared 4, 2 into 3 6, 10 plus 4. So it becomes log 22 minus log 14. This is what is the value of the definite integral. So definite integral is always defining a particular area of the entire curve, whereas indefinite integral talks about the entire curve. So depending on whether the question contains a definite integral or an indefinite integral, our appropriate calculation should differ. So nothing but even if you want to do a definite integral, you should be comfortable with the indefinite integral first. Find out the indefinite integral of that particular value, and after that apply the limits. The higher substitute the upper limit, whatever the value that comes, minus substitute the lower limit, and that is what we are calling as the final solution. Sometimes if I cannot directly use one of the existing models, one of the existing formulas to find out my integration, like we have discussed some 6 formulas right now, if I cannot identify, right now in this case, if you see integral of 9x minus 2, probably let me expand the denominator, 9x squared minus 6x plus 6x. So there is nothing, minus 4. So if I try to do the, if I want to check out whether this is f of x and this is f dash of x, the f dash of x is 18x. So I don't have 18x in the numerator, right? I don't have 18x in the numerator, so it becomes difficult for me to directly solve this kind of an expression. So I don't, if the numerator had been 18x, or in some way it can work out to 18x, then I could have definitely looked at considering it as f dash x by f of x, and then use it as the logarithm kind of a scenario. But because it's not there, or just to give you an exposure to another mechanism, this is where we resort to the mechanism called integration using partial fraction. especially when I have two different factors in the denominator, I will first try to write them as a by some first factor plus b by some second factor, 3x minus 2. Before I apply the integration, I will try to split the entire term, entire this thing. I will try to write it in this form, a by 3, and after that I'll apply the integration. This is called as partial fractions, which means I'm splitting one integrated one into two different things, and after that I can apply the integral separately to each one of them. Now, how do I look at it? So what do I find out as the values of a and b? Now, if I do this as my LCM based method, 3x plus 2, 3x minus 2. So this becomes a into 3x plus 2, and this becomes 3x minus 2, and this becomes b into 3x plus 2. Now I can equate the like terms. So what is the coefficient of x here? In the original equation, the coefficient of x is 9. Whereas in this expression, 3a plus 3b. This is the coefficient of x. And what is the constant term? Here it is minus 2. And what about here? Minus 2a plus 2b. Now I should be able to solve these two simultaneous equations, right? If I simplify it, it is becoming the first one is becoming a plus b equal to 3, and the second one is becoming minus a plus b equal to minus 1. I can add the two. Okay, b 2b equal to 2, which is saying b equal to 1, and a equal to 2. So this entire thing can be written as 2 by 3x plus 2 plus 1 by 3x minus 2. If you try to simplify it, you should get exactly the same answer itself as 9x plus 2. So first I have split the whole fraction into two different fractions using the mechanism of partial fractions mechanism. So you need to really think of, if a question is given, can I do this kind of partial fractions on the question and try to find out the two different fractions like this, and after that try applying the integral dx, which means now the integration can be applied separately. So it becomes 2 by 3x plus 2 dx plus integral 1 by 3x minus 2 dx. Now 1 by x form. 1 by x is log x. So I'll write it as 2 into log 3x plus 2 by 3. Whereas this becomes log 3x minus 2 into 1 by 3. So if you take it inside, so I'll take 1 by 3 out, and using the formula of logarithms, laws of logarithms, I can write it as 3x plus 2 squared. And this also I can write 1 by 3 into log 3x minus 2. Then 1 by 3, if I take out common, I know that the log a plus log b is nothing but log ab. So it becomes 1 by 3 into log 3x plus 2 squared into 3x minus 2. This is what is the integration. So probably you try to do the differentiation of this, you should get exactly 9x minus 2 by 3x plus 2 into 3x minus 2. So what are we trying to drive here? in case a fraction does not contain direct formula of f dash x by f of x, but the denominator contains various factors, I would try to split the entire fraction into two or more fractions by using the method of partial fractions, and after that use the formula of integration to simplify the entire process. I'll do separate integration for all the terms, and after that I can integrate them and simplify that as this is shown in this particular example. I hope you are clear on how to do the integration using the partial fractions kind of a mechanism. Now let's move further. There is one more method of integration which I can do, which is nothing but the method of substitution. So in this example, first of all, there is no direct formula here. So what we can resort to is, we can take a substitution. Okay, if I say the whole denominator 2 into e power 3x plus 1 is equal to some t. Now do the differentiation here. 2 into e power 3x into 3, and this part is 1, fair enough. So this entire thing dx equal to dt. Do the differentiation of both the terms. So this entire thing dx is equal to dt. And so from here it comes out like dx is equal to dt by 6 into e power 3x. Now you can very well find out e power 3x in the form of, so you are trying to translate the whole x into the t form. So when you say 2 into e power 3x plus 1 equal to t, 2 into e power 3x equal to t minus 1, and e power 3x equal to t minus 1 by 2. So you can write dx as dt by 6 into t minus 1 by 2, which is nothing but 3 into t minus 1. Right? So what has happened here? The whole thing, okay, let me just take the indefinite part first. 4, what is the dx here? dt by 3 into t minus 1. And what about the 2 into the 2 into e power 3x plus 1, that is equal to t. So it has become integral of 4 dt by 3t into t minus 1. Again I can use the partial fraction method. Right, so 4 by 3 I will take out. 4 by 3 I will take out, and I can write this in the form of partial fractions. A by t plus b by t minus 1. So this becomes t into t minus 1, a into t minus 1 plus bt. And because 4 by 3 is taken out, there is no t term. So a plus b equal to 0 and minus a equal to 1. Minus a equal to 1. So a equal to minus 1, b equal to plus 1. So I can very well write it as minus 1 by t plus 1 by t minus 1. Now I can very well do the integration. Okay, 4 by 3. So into 1 minus 1 by t. So minus 1 by t, minus I take out, 1 by t is nothing but log t. right? And this becomes log t minus 1. Okay. Now one more thing you can do, 4 by 3 and log t minus 1 minus log t, log a minus log b. You can write it as log a by b. So you'll write it as log t minus 1 by t. Fair enough. Now, what will happen to the limits? So x is from 0 to 1. Now what happens to t now? So what you do is, in place of x you substitute 0 once, you substitute 1 1. So what is becoming, if I substitute 0, 2 into e power 0. E power 0 is 1. So 2 plus 1. So this is becoming 3. And the other one, if I substitute 1, it becomes 2e cube plus 1. Okay, so this becomes 2e cube plus 1. So all I can write it is 4 by 3 into log t minus 1, 2e cube plus 1 minus 1, which is nothing but 2e cube by 2e cube minus 1. This is one term, minus, again it becomes log 2 by 3. This is what is the simplified expression for me. Log 2e cube by 2e cube minus 1 minus log 2 by 3 into 4 by 3. This is one way, especially if I can't find out the expression formula directly available to do the simplification. I can resort to the substitution mechanism. Assume this entire expression to be some t. Then do what is the value of dx. Try to establish all x's in the form of t's itself. Even dx also translate it in the form of dt's. And so even the integral limits, transfer them into the form of t's itself by substituting the corresponding x values, make them into t's, and after that do the integration with respect to t's, because everything, all values are being transferred in the form of t's. So I don't need to again come back, because even the definite integrals have been transferred into t's. Sometimes what happens is, the moment I have transferred it in the form of t, the problem becomes more simpler rather than if I look at it in the form of x itself. So that is where the integration by substitution will help me in simplifying the entire process. Right? So we'll stop this here, though there is a lot more content that is available as a part of integration for ASET. We'll try to take it up as a separate session, because these three methods itself, whatever we have, one we tried using the formulas, two we tried doing the integration using partial fractions, three using the substitution. It's better you practice these three elements before we go to the next part. Until here, if you have any further queries, you can please give me a call on my mobile number, which is displayed below, 98480-12123. You can even email me on vamsidhar@pacegurus.com, mentioning your doubt, and I can reply them back to you. You can also visit the website www.pacegurus.com to get any further updates regarding the various training and consulting assignments which we take up in the areas of finance, analytics, investment, statistics, and actuarial sciences, using the tools like Excel, VBA, and SPSS. Thanks a lot for listening to this session. Thank you very much. We'll again catch up for the second part of this integration in the next session. Thank you very much.